A little bit disappointed, huh? Absolutely not. The short answer is no.
Hello, dear internet users. It's Sana, and you're watching Science. I've been recently graduated with my master's in inorganic chemistry. In today's video, we're going to talk about the science behind Netflix's new show, Three-Body Problem. As you may know, it's an adaptation of a trilogy book with the same name by Chinese author Liu Xin. I'm sorry if I pronounced it wrong. Published in 2008. Okay, so without further ado, let's dive into the story.
The following video contains spoilers, so if you have not seen it yet and you are planning to do so, please stop right here and come back. After you watch all of the episodes, don't worry. You won't miss anything. When you come back, we will be right here.
Please like this video and share it with your family and friends, and don't forget to hit the subscribe button.
Okay, let's see what Wikipedia says about the plot of the show. Ye Wenjie is an astrophysicist who saw her father brutally murdered during the Chinese Cultural Revolution. Later, she was conscripted by the military because of her scientific background and sent to a secret radar base in a remote region. Her fateful decision at the base echoes across space and time to a group of scientists in the present day, forcing them to face humanity's greatest threats. From what I gathered, the 8 episodes cover Book 1 and approximately half of the Book 2. I won't lie and pretend that I read the books before stumbling across the first trailer of Three-Body Problem in YouTube accidentally. But I did read the books before watching the show, and I also watched the Chinese adaptation made in 2023. You should also check that out. It has 30 episodes and almost religiously covers the book 1, unlike her Netflix sister. By the way, the books are great and you guys should also read them, but I don't think that it is mandatory to read them and then watch the Netflix adaptation. I think that some of the differences in the plot between the book and the show are related to the fact that the book 1 main events happened in 2008, while the Netflix adaptation in 2024. This kind of large gap, especially with all the scientific improvements these past years, probably answers to many of the plot changes. Okay, I sense some of you yawning behind your screens and wondering when is she going to say her priest and get to the damn point. I promise I'm not going to bore you with all of this nonsense babbling further than this. And now we're going to talk about the real stuff. How much of the science shown in Three-Body Problem is real?
The science shown in the Three-Body Problem can be categorized into 3 categories.
And some other sub-science categories which I will talk about in another video if this one receives well. Let me be honest with you guys, we are a really small channel and we need to focus on views. I need to feed my family too. I'm not going to waste my time and lecture you all a course in nanotechnology or the other 2 categories. Instead, I'm going to ask questions and answer them with minimum requirement of previous knowledge from you, while trying my best to make it understandable for you guys. Is it alright with you? Okay, shall we continue? Where was I? The nanotechnology discussed in Three-Body Problem. I think we're really lucky that the showrunners decided to completely drop the ridiculous nano-circuits idea in the show. It would be absurd and honestly hard to explain. Just imagine a circus from Earth to Moon made out of nanomaterial. I guess it was a radical imagination in 2008. But now it is more like Marvel, not science fiction. No hate to Marvel though, I'm a huge fan of them. Shout out to Doctor Strange. Okay, I think I'm speaking for all of you when asking this question. Is it possible for nanofiber, or in this case several nanofibers, to cut a ship in several chunks?
Okay, first let's tackle the question. What is a nanofiber? But before that, we need to understand some basic nanotechnology terms. The first term is nanomaterial. We live in a three-dimensional world, time aside. And nanomaterials are materials that in at least one dimension measure between 1 to 100 nanometers. For instance, nanosheets have 2 dimensions in the nanoscale. Now that you know what is a nanomaterial, we can move further to the term nanofiber. What is a nanofiber? As the name suggests, nanofibers are fibers with diameters in the nanometer range. There are various methods to synthesize nanofibers, but let's not get bogged down in the details. This isn't a science class. What baffles me is that Augie Salazar, which I guess is the female version of Wang Mao in books, clearly states to Dashi,
Why? What are my nanofibers going to do against them?
my question is that what they used to slice the Judgment Day in several pieces, was it nanofibers or like nanowires? Because these are two different concepts and materials. Nanofibers are typically long, flexible structures with diameters in the nanometer range. They can be made from a variety of materials, including polymers, and are often used in applications like filtration, tissue engineering, and drug delivery due to their high surface area to volume ratio. While nanowires, on the other hand, are usually more rigid and shorter than nanofibers, they have unique electronic, optical, and mechanical properties that make them suitable for electronic applications such as sensors or flexible transparent electrodes. Okay, assuming that they use nanofibers, could you string them across the Panama Canal to slice a ship like Judgment Day, a reverse tanker oil ship? I'm already sorry that I must disappoint you all, because the short answer is no. Nanofibers are known for their large specific surface area, excellent flexibility, and superior mechanical properties, which make them suitable for a wide range of applications. However, the use of nanofibers for cutting large objects like ships is not a common application. Cutting large metal structures typically requires methods that can handle the toughness and thickness of the material, such as oxyfuel cutting, plasma cutting, or even water jet cutting. Nanofibers, due to their microscopic scale and properties, are more commonly used in applications like filtration, drug delivery, tissue engineering, and sensors. While nanotechnology may contribute to the development of new cutting tools or materials, the direct use of nanofibers to cut through large, dense materials like ship steel is not currently a recognized application. The strength and durability required for such a task will likely exceed the capabilities of nanofibers as they are understood and utilized today. So, no, we can't use something like nanofibers to cut a ship like Judgment Day. A little bit disappointed, huh? Now let's continue and get on with other categories. Let's talk about quantum and modern physics. The books, and even the series itself, provided us with so many concepts in this realm of science. But one question probably stands out. Are Suffins real? Can we make them? Let me quickly describe Suffins for you who are spoiling yourselves without watching the show first. Don't do that. Okay, anyway. As three Solarians, or in the show Santi, plot their invasion of Earth, they realize that Earth's rapid scientific advancements would surpass their technology by the time their fleet arrives, making it a suicide mission rather than an invasion. So they create Suffins by unfolding a proton into all 11 dimensions, embedding a supercomputer, and then folding it back to 3 dimensions. These Suffins, entangled by quantum entanglement, allow them to spy on Earth in real time and even interfere with modern physics experiments. They would interfere with the experiments being performed at colliders and other crazy stuff. such as making the stars blink for a certain person or like the craziest countdown Augie saw. These are all results of the hardworking Suffins working day and night to keep science on Earth at bay. Look, I really tried to oversimplify what they did in books and the show. So now that we are all on the same line, the question still remains. Is it possible to fold and unfold proton like this? You see, there is a theory here that I think introducing it to you guys would help us understand this bizarre procedure a little bit more, and it is string theory. You may have heard of it, so what exactly string theory is? Again, I will try and simplify all of these terms in a way that would be understandable for the majority of you guys. And I know that in doing so, I may decisively omit some of the more scientific parts. For all of my fellow researchers and scientists, forgive me for overly simplifying matters in this way. I just think that not everyone should be a scientist to enjoy the wonders of science. That's all. Okay, back to the string theory. The core idea of the string theory is that the point-like particles of particle physics are actually one-dimensional strings that vibrate at different frequencies. These vibrations determine the properties of the particles such as mass and charge. The theory suggests that everything in the universe, from photons to quarks, is made up of these tiny strings. Unlike traditional particle physics, which models particles as zero-dimensional points, string theory's one-dimensional strings can join or split, giving rise to the interactions we observe as forces in the nature. String theory also posits the existence of additional spatial dimensions beyond the three we experience daily. These extra dimensions are thought to be compactified or curled up in such a way that they are imperceptible at human scales. Okay, so now we know where all these 11 dimensions I mentioned earlier come from. Is it possible? Maybe. In theory, yes. Can we do it now? Absolutely not. It's a purely theoretical question, and we can even joke that we're being blocked by the Suffins themselves. Last but not least, let's discuss the planet Solaris with its three suns. We're entering astrophysics territory now. Has a planet like Solaris been discovered in real life? Or, as the show states, Santee? What really is the three-body problem? Let's start right there, from the three-body problem, and work our way up to the Solaris with its three suns. What is the three-body problem? The three-body problem involves predicting the motion of three-point masses based on their initial positions and velocities. It's relatively easy with two bodies, but with three, the motion becomes chaotic. Historically, one of the first examples to receive extended study was the system involving the Moon, Earth, and the Sun. Because the Moon is relatively smaller, we simplify the problem by treating it as a two-body problem. We omit the Moon. But we can't do the same with the three massive suns of Solaris. Now we understand the inspiration behind the name of the book and the series, it's time to address the real question. Has a planet like Solaris been discovered in real life? On September 29, 2021, Nature Briefings quoted from New York Times a new discovery. A bizarre feature in a distant star system might be caused by the first known planet that orbits three stars. GW Orionis is surrounded by a spiraling disk of gas and dust, typical for a young star system. But this disk is split into rings, and the outer ring is tilted at an angle. Detailed modeling of the system suggests that the best explanation is a giant gassy planet carving out its orbits in its first million years of existence. It may be the first evidence of a circumtriple planet carving a gap in real time, says astronomer Jeremy Smallwood. Interestingly, in 2019, astrophysicists discovered a planet with 3 suns, but there was a catch there. Scientists found the world, which they've dubbed LTT 1445AB, in data gathered by NASA's Transiting Exoplanet Survey Satellite TESS. LTT 1445AB orbits just one of the 3 stars, all of which are red dwarfs in the latter half of their lives, and the system is about 22.5 light years away from Earth. If you're standing on the surface of that planet, there are 3 suns in the sky, but 2 of them are pretty far away and small looking. Co-author Jennifer Winters, an astronomer at the Harvard Smithsonian Center for Astrophysics, told New Scientist. They're like 2 red, ominous eyes in the sky. So, it is possible to find a planet with 3 stars, but the stability of planetary orbits in multi-star systems can vary greatly, and while some may have irregular orbits that could lead to variable environmental conditions, none have been observed with the dramatic changes depicted in the book and the series. In reality, the long-term stability of a planet's orbit in a multi-star system is a complex and ongoing area of research in astronomy. At the end of the day, science fiction is sadly mostly fiction. But it sure as hell will not stop us sci-fi fans from constantly reading, watching, debating, and for fortunate ones, the books. But our time clearly does not allow us such luxuries to discuss every one of them. Hope this video helped you all to understand the science behind the show a little bit more, and I think it would be enough if it just kicked something in your brain and picked up your curiosity. And as always, please like this video and share it with your family and friends, and don't forget to hit the subscribe button. We're all still trying to find our place here on YouTube, so stay tuned. Do not hesitate to comment and ask questions. If you have one, we will answer to them. Go and watch Trip Body Problem on Netflix if you haven't seen it yet. And why are you here if you did not? It's Saina and you're watching Science. Bye!